Okay. So for the past 3 or 4 days or something like that, I've been thinking about some changes that I'm going to have to make to blockhead internally. So let's see. So blockhead is written in a very sensible way, which is it's an audio program, right? So you have how to draw this. You have a UI thread, and you have this real-time audio thread. So I'm just drawing with a mouse here. And so when the user does things in the UI thread, and these are, okay, I'm using the word thread here. There is a UI thread and an audio thread, but these boxes could also be thought of as like abstraction layers. It's like the UI module and the audio module, and these sort of communicate with each other in, if I'm doing things correctly, they hopefully communicate with each other through some kind of organized interface where this bit is where all the complicated stuff always happens, but that's where all the complications arise. But because these threads have to synchronize data between each other in some kind of organized way, usually it's UI data going to audio, but occasionally audio has to go to UI for like visual feedback and that kind of thing. So the way blockhead works is, so this is pretty typical, right? You separate the UI from the audio thread. So it's like a two threads, 2 modules. And so the way blockhead works is I have this this immutable data structure, which we could call a model, containing everything that the audio engine needs to play back the audio. Everything's sort of hopefully organized in some kind of cache efficient and audio thread friendly way. It's all the data is sort of organized and formatted in a way that is friendly to the audio thread. But in the UI thread, it's just this. I have a bunch of like object-oriented bullshit going on. So I have all these objects going on. They could be anything. It could be like a track or a block or a lane or something like that, and they're all contributing to this model. So they're all like adding every time one of these objects updates in the UI thread. It's like updating the model every time it updates. So it's all contributing to this model. Everything happening in the UI is like being assembled into this audio engine model. And then we have some kind of complicated lock-free synchronization strategy going on to actually get the model to the audio thread. So that is just to make some space here. That's basically how blockhead has worked for a long time, and it's a perfectly sensible way of doing things. The problem with this approach, there's two main problems with this right now. At this point in development, blockhead has got to the point where this is not scalable anymore. So the first problem, I'll start with talking about recursive macros, since that's sort of an exciting thing that people might be interested in. So blockhead has these macro things, right? And it also has this cloning thing, so you can create a clone of a macro. So this is the same macro twice. You can just enter it from different places. And you can also create more macros inside of a macro. So I call these nested macros. A macro with a macro inside of it, and it can go infinitely. So when people see this, sometimes very adventurously minded people will have the thought, can you, because you have this cloning thing, right? Can you create a clone of a macro and put the clone inside of itself to create a recursive macro? And the answer is no, you can't do this. So at the moment, I have this list of blocks. These are all of the blocks that exist in the project. I was about to say that macro blocks do not appear in this list. They're not supposed to. So this is a bug. Macro blocks should not currently appear in this list. I'm surprised I have not received any bug reports about this actually then. Because the reason that macro blocks should not appear in this list is this: when you create a block from this list, it creates clones. So you can see this is created a clone here. So this provides an interface. Oh, this is that bug that people were... Yeah, this assertion failure. And then it crashes. Yeah, I need to fix this. I shouldn't be using this version, this build. I think it's it's actually worse than 0.4. I'm going to try and fix that later. Actually, I've already fixed this. I've already fixed this bug. But it's in another branch at the moment. And then it really hangs. Yeah, like people were saying. You have to task kill it. Ooh, that's pretty heavy. So I don't think this will happen here. So let's go back to what we were doing. Create a macro. So macro should not appear in this list because this basically provides an interface to take a macro and put a clone of it inside of itself. And I assume this will just crash if I try to do this. Yeah. I mean, that's why it's frozen. Probably because it's just burning the CPU right now. Eventually it's going to Stack Overflow because it's trying to generate the engine model for this recursive macro block. And of course it will never finish because it's just recursive. Yeah, there we go. So yeah, that's I'm surprised no one's reported that actually. I guess people aren't adventurous enough to even try putting a macro inside a macro of it inside itself. Nobody's had that thought yet, I guess, when actually playing around. But so you might think to yourself, well, of course, that's impossible to implement. But it's not, because what you can do is you can just detect that feedback loop. And when it comes to generating the data for the engine, the audio engine model, you could just have a limit on the number of times it recurses. So it could recurse like 10 times, for example, and then stop and just say, well, that's the whatever the output is of that many recursions. It could do if it would be a user setting to decide how many times a recursive macro can recurse. The problem with that is with the way that things are set up at the moment, with this architecture that I have, I don't even want to think about how to implement detecting those recursive macros and I just said I don't want to think about it. I just started thinking about it then, and my brain stopped working. I couldn't even say words anymore, as you could hear. So yeah, it's just too this architecture is just it's too like brittle and I don't know what words to use, but it's just not an appropriate architecture of doing that kind of logic, because that's quite a complicated thing. And the crucial point is that all of the logic would be happening in the UI thread also. So it's all sort of intertwined with everything else that the user is doing. And there's no like clean separation of, well, I'll talk about how I want to improve this architecture in a minute. So the second issue with this architecture is, bearing in mind, every time the user does anything, all this processing of generating this new model is all happening in the UI thread. So this is like the UI. I mean, I should really put some kind of box around here to say this is the UI abstraction layer. So the other issue is performance related. So if I have something like this, sorry if that's a bit loud, and then I have a manipulator doing something, like this maybe. Then I create a macro out of this. Then clone that macro. Then do something like affect parent blocks. So this manipulator is going to search upwards through the macro hierarchy, and it's going to affect things above it. And then inside we can create another macro from this. So this has still got another manipulator which is searching upwards through the macro hierarchy and affecting these samples above it. You see that? And just create another macro inside it again. So you can keep going infinitely, there's no limit. If you do this for long enough, obviously every time you're like creating another clone or copy of this macro, here I'm like 3 macro levels deep. When I'm moving, because this is set up to affect parent blocks, when I'm inside this macro, 3 macros levels deep, every time the user is moving this left and right, I'm searching all the way up to every level of the macro hierarchy for everything that this manipulator is intersecting with. Also, I could create a clone of this entire thing now. And now every time I move this, it's going all the way up through this macro hierarchy, but also doing the same thing again for this other instance. It's like searching through the entire workspace at every level for everything. It's basically searching for like, what am I intersecting with, and then it's generating the new pitch envelopes for everything that it's intersecting with. And you can keep like doing this infinitely. You can just create like massive spider webs of manipulation and processing that has to happen every time you move things. Sorry. So eventually, if you do that for long enough, things will start to get really laggy. Like when you're dragging this from left to right, it will be like so if you're a software developer, you might just say, well, it needs to be optimized, right? All that processing that is happening, you just need to optimize it and make things really cache efficient or whatever. Problem is that's not a solution to this issue because this is creative audio software, right? And there shouldn't be any software imposed limitation on the number of macro levels that you can write or the amount of stuff that you can do. The only limitation to the end user should be their hardware. And so it's all well and good like optimizing these algorithms that are happening, but it literally doesn't solve the problem because you could optimize it as far as it possibly can be optimized, and the user will still be hitting that limit of like the UI will eventually start lagging because they'll just do more and more stuff. The more you optimize, the more and more stuff the user will do. And okay, so you might be saying, well, of course, there's going to be some limit because, I mean, computing power is not infinite, and eventually you're going to hit a limit, and the UI is going to start lagging. I don't accept that argument because when you think about what is actually happening when the user moves this block left and right, even though it's like it's doing all of this invisibly, it's doing all of this extra work where it's climbing up through all of these macro levels and finding everything that it intersects with and generating these pitch envelopes. All that's happening invisibly. The only thing that's happening on screen, like in the input thread, the input processing thread, where the user is like clicking, moving the mouse and releasing the mouse button, the only thing that's happening, I mean, you can see it, it's right, there's a little bit of processing happening at this macro level, like, so it has to update this block here. But ultimately, anything that's happening is we're processing the mouse input. This rectangle thing is moving from left to right or right to left on the screen. There's no reason why all of that extra work should be blocking the UI thread. And so, yeah, obviously what I'm talking about here is multi-threading. So, when the user does something that triggers a bunch of processing that has to be done, it should just trigger it in a different thread. That's in a roundabout way. That's what I was trying to say. So at the moment, every time I'm moving this manipulator, it's going through all of these macro levels, the entire hierarchy, and doing all of this processing that it has to do. And all of that is happening in the UI thread. And if there's too much, then it will start lagging. So my alternative architecture that I want to do is let's do a different color. We have the UI thread. Still having all of these stupid object-oriented objects floating around. But these will instead contribute to a sort of intermediate input model. Let's call it an input model. So all of this UI data is sort of assembled into this input model. So for example, when I'm moving this manipulator and it's searching through the hierarchy and figuring out what manipulations it needs to do and performing them also, that's all quite a lot of processing. But I'm not going to do that processing in the UI thread anymore. All I'm doing is updating the positions of objects in the workspace, basically. So I'm just updating the position of this manipulator, and all of the extra work has to be done in response to changing that position, or changing the size, or changing the envelope, or whatever. All of that extra work that has to be done is going to happen in this this extra thread. It's like an intermediate thread that happens here. And the job of the intermediate thread is to do all of this expensive processing. And so this audio engine model is now going to be this output model. Output model. Sorry about my mouse writing. So it just takes the UI model, the UI state basically, and generates audio engine state. So it does all this, all of the expensive processing happens in here. And then synchronization between this thread and this intermediate thread will be much easier because we can use mutexes and things, I suppose. But then we're going to have this same synchronization eventually between the intermediate thread, the processing thread or whatever I want to call it, and the audio thread. So I guess this is basically the same. It's getting really complicated now. But anyway. So essentially there's no interaction anymore between the UI and the audio thread. I haven't thought about, obviously sometimes the audio thread has to send data back to the UI thread. Haven't thought about that yet. Might have a separate abstraction layer for doing that stuff. Another one down here for sending data back. I don't know, because that's I mean, the semantics of that stuff are just completely different to sending from UI to audio. So that's basically what I want to do. What was I going to say? Right, yeah. This is going to be a big refactor and it's going to complicate a bunch of things, but it's going to simplify everything. It's going to, right, oh yeah, that's what I was going to say. So, the problem of recursive macro blocks, it's not like this completely just solves the problem, but it makes it much, it vastly simplifies the problem of implementing that, because I just have this input model and this output model. These are basically just immutable data structures. And all of the logic for like detecting a recursive macro loop and generating an appropriate output model, it all just happens neatly in this like confined place. So I just have this one big input and this one big output. So it should be a lot easier to implement that once I have this kind of an architecture. So the other issue is when you bounce a block. So I just bounced that to a new sample. How does bouncing work? And this goes for baking as well, actually. When you bounce a block, the way this is implemented at the moment is it looks at in the current model, this one at the top. So this is actually not drawn correctly. The way this works is I have these objects in the UI thread, and each one of them has like a tiny subset of the engine model, the engine state, or a couple of little data structures, which they update, and then these little bits of state are sent to the model, and then there's a little bit of processing here to assemble it into the model. When you bounce a block, I create these things called snapshots. It's just a word that I use internally. And a snapshot is basically, I'm gathering all of the engine state that I need, like a stripped down version of the project data, which is just the data that is required to render that block to a sample. And so if I bounce a selection, for example, it will gather all of the data that it needs for this block and all of the data that it needs for this block. And it assembles it into a thing called a snapshot. So it's basically looking at these little pieces of state, and it's assembling them into this thing called a snapshot. And that is used, that's sent into a background thread to render the bounced sample. So in the new architecture, these little bits of state are not going to be present in the UI thread anymore, because the only thing I'm updating is these actual objects here, these objects, and I'm just putting that state into an input model, and then these little bits of state are generated here, and then eventually get to the engine model. So snapshots are going to have to work differently. But yeah, yesterday I think I was in the shower and I realized the whole problem of I should mention also snapshots. This same snapshot mechanism is also what's used for baking. So when you're not editing a you see, when you're editing a block, the waveform disappears. It's because the engine will process this block in real time, and then as soon as you stop editing it, it'll bounce it to a sample, and that's what the waveform is. So that bouncing to a sample, it basically uses the same mechanism as when you do a manual bounce. Okay. And it works because this engine state is always just available immediately in the UI thread. So when you right click and say bounce, it all just happens in the UI thread. Like the assembling of that snapshot is really quick to just generate this little snapshot. And it uses these are like little immutable data structures under the hood. So they're quick to copy in. But then it sends it to a background thread and generates the bounce. But yeah, in this new architecture, these pieces of state are not going to be available anymore. I realized in the shower or wherever I was that this snapshot system is completely simplified by this, actually. Well, in fact, I could have just simplified it already, but I didn't. It's going to be much better, actually, yeah. Because what I can do is simply just take a copy. Every time I need to bounce a block or a selection of blocks or do some kind of bouncing operation that I was using this snapshot mechanism for, I'm basically going to throw away the snapshot system. I'll keep some parts of it, a little like the top layer of it. But I don't need to define these like stripped down versions of the state anymore. All I need to do is I can just take a copy of whatever the latest version of the engine data is, the engine model. I could just take a copy of the entire thing. And so that's going to contain the data for the entire project. most of it will not be relevant. Like if I'm just bouncing some block, it might just be referencing like some little parts of the state inside this model. But because this is an immutable data structure, you can copy it really quickly because it's not like a true copy. So I could just take a copy of the entire model, just, read the actual data that I need. And if this, if a processing step is currently in process at the point that the user tries to create a snapshot, then we could just block until it's finished, until a new version is available. So that's slightly different because previously this was all happening in the creation of this snapshot was all happening in the UI thread, and then the processing of the snapshot was happening in a background thread. But now what I'm going to do is, when a snapshot needs to be created, I just sort of create a description of what the snapshot will be, and then in a background thread the actual snapshot will be created from that description by taking a copy of the entire model, and then it does the processing. Part of the reason why I wanted to make this video was I thought that saying it all out loud would make things clearer for me, but it's actually made me more muddled than I was. I feel like this was very clear to me when I was just thinking about it on my own. And now I've just confused myself. So this is interesting because I don't do this kind of stuff very often. Usually when I'm trying to solve this kind of complicated stuff, I'm just in my own head thinking about it. And I thought as an experiment I'll try and like talk out loud about it and scribble some diagrams, and it's like 1,000 times worse. So I probably won't do this again because it's not helpful, actually. It's more helpful to just like do what I usually do, which is lie down on my sofa with my eyes closed and just think about it. But I think this idea is sound. This is going to happen. It's going to have to, I don't want to work on this right now because it's going to be, I don't know how long this is going to take, maybe a month or two. And I've got other things I need to work on at the moment, like bug fixes for the current build. But this is going to have to happen before the instrument system, because it has ramifications for the instrument system. But the important point is that when I have this like intermediate processing thread where I just have the entire input model and the entire output model here, everything, it just simplifies a lot of stuff. It makes things more flexible and easier to reason about these complicated things, such as recursive macros. Like I can almost just solve the problem of recursive macros in my head once I have everything neatly organized into these immutable data structures, where it's just like I have this input model, I'm just generating an output model. Again, I haven't thought at all about sending data back to the UI, which is going to have to happen. Is there anything that I didn't think about, didn't talk about that I was thinking about?